Hello, students. Welcome to another week of science. This week, we're going to be focusing on measurement and the metric system. So hopefully this should be stuff that you're a little bit familiar with, although the metric system stuff might be new. Today, specifically, we're going to talk about what scientific measurement is. So you should have a packet of PowerPoint slides that look like this. So what is measurement? So giving a number value to something is what measurement is. So for example, we could say, well, from here to there, I ran from here to there. But since you can't see me right now, how do you know what I mean by here to there? Maybe I say I can run faster than you from here to there, but I could be talking about a mile. I could be talking about 50 kilometers, 100 miles. It makes a big difference on how far we're talking about. So we use numbers that everyone understands and is common to everyone, so we can talk about things to other people and have it make sense. So I have this picture here that shows that the crayon is shorter than the pencil, but how much shorter, right? So that's what we want to know, and that's what we use measurement for. So it allows us to better communicate or talk about things. It doesn't always have to be numbers, right? But like here, they use paper clips. But that's why it's important to have it be things that we understand and we all know that it means the same amount. Because if you say the pencil is 4 or 5 paper clips long, 5 paper clips long, like in this first picture, if you're not using the same paper clips, you might think that's a much longer pencil if the paper clips are the size of the paper clips in the second picture. So and that's important for tracking like coldest amount of things too, or like records. So sometimes we say there's like different eras or stuff, right, with records and sports. Like in baseball, they have different home run eras and stuff based off of what those numbers mean. So how do you use measurement? So you probably use measurement a lot in a lot of different ways, maybe some ways that you don't even realize you're using it. So you can measure how much time you have left to sleep before your alarm goes off or before your mother wakes you up. I know a lot of times I'll wake up and I'll look at my phone or my alarm clock and say it's 5:30 a.m. and roll over happily because I know I have another hour to sleep before I have to get up. You might also measure how much of an ingredient you need to add to whatever recipe you're using for cooking. So if you're using like measuring cups, right, that's a way of measuring. Or maybe you measure a piece of wood to build something. There's all sorts of things you can measure. So I encourage you to think of some ways that you can measure things because you're going to have a chance to do that for tomorrow's work. So measurement in science. So why do we use measurements for science class and science in general? We want to make sure that we're accurate because it allows us to communicate with scientists from all over the world. So for example, you guys all did the Penny Lab. Students all over the United States do the Penny Lab every year. So you could compare your results from your Penny Lab with students from Ignacio High School, where I was at last year. And you could say, this is what I got for my lab results. What did you get? And since you're both measuring a number of drops, you could discuss those and they would make sense. And make sure that because of that, we want to make sure that we're measuring things the same way. We also want to make sure we're using the same units. So units are usually what you see at the end. So like inches, feet, it's like it gives the number more meaning. So instead of just saying 12, I ran 12. Well, did you run 12 feet, 12 miles, 12 yards, 12 meters, 12 kilometers? Those have a different length, right? So even though measurement is assigning a number values to something, the units in the system we use gives it even more meaning. So you're probably used to the customary system. That's what we use here in the United States. So inches are an example, feet are an example. I'm going to show you more examples in a minute. What all scientists all over the world use is called the metric system. And you've probably heard of the metric system too. The reason why we use the metric system is because the metric system is based all around the number 10. So those of you that have been learning about scientific notation and exponents, it makes it much easier to do problems when we just have lots of zeros because we can move the decimal point around to change, like convert between different units within the metric system. And you're going to see that when you do the metric mania assignment later this week. It makes it much easier to change those units and communicate. It's a lot easier to remember those conversions without having to look them up, and it makes the math a lot easier. So there's a lot of reasons why the metric system just makes a little bit more sense, and that's why we use it all over the world. So an example, metric system, so meter stick would be an example of metric system, yardstick is part of the customary system. So here's some examples of different units. So for customary, we have feet, inches, cups, gallons, quarts, miles, pounds, probably all things you've used. If you've ever been to Canada, they measure things in meters, centimeters, liters, kilometers, kilograms, grams. In science, we use moles to talk about how much of something there is. That's not really common in everyday life, but that's something we'll use in science class in the future. If not this year, then definitely in high school. So those are just a few examples. There's plenty more. So how does the metric system work? So each type of measurement you could take has a base unit. So we have this one that goes in the middle. So for example, meter would be the base unit for length. Liter would be the base unit for volume. So how much liquid there is. And then we add prefixes to show how much bigger or smaller something is than that base unit. So for example, you probably have also heard of centimeters. So, right? So centimeters. So if you think about the word centi is also in the word century. It's in centipede, right? We say centipedes have 100 legs. Centi means 100. So remember, centipede, 100 legs, centi means 100. That means that when you put the word centi in front of meters, you're saying that there's 100 in 1 meter. So there are 100 centimeters in 1 meter. And I challenge you, if you have ever seen a meter stick or you have access to a meter stick, if you look really closely at it and you count all of the little tiny dashes, there will be 100 centimeters in that meter stick. So another example is if you've ever heard of kilo. I don't have any cool other words that go with kilo, but kilo means 1,000. So there are 100 grams in a kilogram because it's 1,000 times bigger. Centimeter is 100 times smaller than a meter. A kilo is 1,000 times bigger than a gram. So gram is how heavy something is. And again, you're going to have a chance to work with and practice the metric system, and I have a nice graphic on the next slide as well as on your metric mania activities. So this kind of shows how much bigger and smaller. So your base unit would go right in here. So if you put meter, oh, I ran out of space here. So if you put meter right here in the middle, if you put deca in front of meter, so if you do m or meter, that would say that it's bigger, right? It's getting bigger, so there's no decimal point. That would mean that there's 10 meters in 1 decameter. 1 decameter. And same thing as you get bigger, right? So if you've heard of like a gigabyte, like how many gigs of memory does your phone have? Giga means big, right? Same with tera. If something has a terabyte, that's pretty darn big. There's 12 zeros, extra zeros on there. Whereas really little things like pico, nano, if you've ever heard of like a nanometer, it's super small, right? Or micro means small, like microbiology means the study of small things in biology. Those all mean really little. And you can tell, again, if you're been learning about exponents, there's a negative on those exponents. That means it's really small, whereas these are large exponents. So it's a really big number. And then the last thing I have for you is how can you remember all of these numbers? So you don't need to know all of these. We're never going to use exa in this class, or peta, or atto, or femto, other than maybe for a little bit of practice, but we're never going to use that. We're never going to be doing something so small, even with nano or pico, where you have to measure something that tiny, because it's really, really small. However, there are a couple that you should definitely remember and should become familiar with. So how can you remember the ones that you do need to know? Just think King Henry doesn't usually drink chocolate milk. So King Henry, we really like kings in science for these acronyms. But K for kings will stand for kilo, H for Henry stands for hecto, D for doesn't stands for deca, U usually stands for unit, so your base unit. D in drink stands for deci, C in chocolate stands for centi, and M in milk stands for milli. So notice you only need 1, 2, 3 steps up and 1, 2, 3 steps down. So you don't need to know a ton. That's 6 total. So we get as big as 1,000 larger than our base unit and 1,000 smaller. So milli, there's 1,000 millimeters in 1 meter and 1,000 meters in 1 kilogram. And again, you'll have plenty of time to practice with that. So that is the end for today. That's all you have to do for Tuesday, October 27th. And then you'll have a chance to look up some measuring tools and practice with this later in the week. Feel free to call me or send me a message on WhatsApp if you need extra help or have some extra questions.